Well, hello everyone. This is KP the Math G. Busy summer. Well, it's not quite summer officially. We might as well be direct, but the weather's like it's summer, and we've just been busy with gardening and well, we capture animals like groundhogs and what do you call those? Yeah, raccoons. And we carry them way off, at least 5 miles away, and we put them in a safe place near water where they can survive there. All right, well, keeping them out of our garden and eating all of our food up, I tell you, that's a chore. But anyway, I'm just happy to be here and to be with you today, and hopefully you'll get something out of this video. This is my last 2015 that I'm going to do. I've been into 2016. I did practically all of those problems. I'm going to look at 2017 as well, pick a few problems from those, and just kind of see where we go from there. I want to try to get up to 150 videos. I'm at 136 right now, and I'm just pleased. I'm just delighted to be able to do calculus with you guys. All right, well, let's try this. And if there are teachers out there, I'm no expert, but I may, especially for those of you who have just started teaching calculus for the first year, I know for a fact that if you are watching this, that you're going through some anxiety times. And I'm sure you've been to those workshops where they will help you there. A lot of teachers are there to help you, and you watch this video, watch my videos, and you'll see what I can do any way I can do to help you, whether you're a student or not. But anyway, all right, let's go ahead and get started with the problem. This is a 2015 question number 3. Here's a table here. Oh, there's a negative number. Matter of fact, I got this in a workshop myself. I saw this problem and I didn't, what do you do with that? Anyway, we're going to look at this. You remember, now, velocity can be positive or negative. Speed cannot. Speed's always positive. But the velocity could be positive or negative depending on if you're going forward or backwards. Doesn't matter. You can go in two different directions, but you can still go back up at a certain speed too, So anyway, Johanna jogs along a straight path. Her velocity is given by a differentiable function. We know if it's differentiable, what do you know about this? Yeah, it's continuous. Okay, that's good to know. Explain the meaning of this, and we're just going to look at B for now. Well, we might get into C and D. Hold on just a minute. Let me see if I can figure out what I did with my problem here, because I have it. There it is. Okay, I usually have that out right at the front, and I moved it for whatever reason. Okay, there we go. I'm skipping A. That's pretty straightforward. If you want me to do one like that, I will do it, but I mainly want to get involved with this. Okay, so let's see what this is. This is an absolute value bar right here. Anytime I see velocity and I see an absolute value bar, I know that when I take the velocity, the antiderivative of velocity, or the definite integral of velocity, I know that I'm either getting some kind of distance, right? So this is going to be some kind of distance. In this case, the absolute value means I'm looking for, yeah, that's right, total distance. All right, well, let's look at the total distance. All right, so let's see. We got to use the Wright-Riemann sum. Okay. If I may, I would like to erase some of this. Let's look at this. Okay. I can probably put some of the problem right up above this. Alright. Well, the meaning is this is total distance. Okay. Alright, well, let's look into that. Let's get a different color, if we will, and let's talk about the total distance. Now, we are going from 0 to 40. We're taking the absolute value of v at t dt. Alright. Approximately equal to. Alright, now you got to remember too that the t values represent delta t, right? Okay, so this is delta t, this is 12. From 12 to 20, that's 8. From 20 to 24 is 4. And from 24 to 40 is 16. I want to say that's right. 6 and 4, 4 and 6 is 10, and then that's right, 16. You're going to use these four for either left or right, either one. So that's kind of what you're looking at. So if you were looking at the left, you would say 0, 200, 240, and negative 220. But in this case, it's absolute value. We're gonna start with 200. So this is 12 times 200. I don't care what order you put this in, as long as you do it correctly. Alright, plus 8, and it's supposed to be 4 subintervals, so we're going to have 4. 1, 2, 3, 4. 240. That's all you can get out of this. Now, they put the absolute value bar around it. I'm taking the positive of it. The absolute value of positive is positive, so okay. And then I'm taking 4, in this case, the next number over, times, now, not negative 220. If you want displacement, you're going to do negative 220. But since we're dealing with total, you are taking the absolute value of that. So now 16 times 150. And that is what you're doing there. Okay, just making sure. The answers are, okay, so this will be 2400. Okay, 2400 plus, let's see, 1920 plus 880, I believe it is. 880, of course it is. And then 16 times 150 is also 2400. And when you add all of this up, it is 7,600. Now you want the right units. So since we're dealing with meters per minute, when you take the antiderivative, it's going to be distance. The distance is in meters, okay? And I've already verbally said what the meaning is. This represents 7,600. This represents total distance. There it is, total distance. This, absolute value of v at t, absolute value of v at t each time. Each one of these is what you're doing. You do a left approximation, you do these four here. If you want to do trapezoidal, you can do left and right, and then take the average of the left and right and divide it by 2, in other words, and then you'll get your trapezoidal. If you want to do midpoint, you would pick 12C and then 24. Likely you skip something like that, maybe. I have to kind of look back into those and just make sure everything's right. But anyway, that is B part. Now let's see. I think I can erase some of this now. So let's go ahead and look at this. Okay. All right. That's a cool. I like this problem here. I remember saying, oh, what am I going to do with this negative? Well, you make it positive if you're going to look at total distance. That's what you do. Simple as that. That's what you're doing there. Okay, now we have a different function, and he is Bob. Let's see, this is Bob is riding his bicycle along the same path. Alright, so 4, and we're looking at, oh yeah, t between 0 and 10. Sorry about that. Bob's velocity. Alright, so Bob's velocity. Alright, now that is given by b at t, b at t. Alright, is equal to t cubed minus 6t squared plus 300. Alright. Alright, now it says that this is in still meters per minute. Okay, so meters per minute. This is velocity, by the way. This is the velocity equation, I do believe. Yeah, the velocity is modeled by this. Okay, now if you I want to look at Bob's acceleration. Okay, so Bob's acceleration. And I want to say it's at t equals 5 minutes. Alright, I want to say, yeah, at time t equals 5. Alright, well, that's what we're looking for. What is Bob's acceleration at t equals 5? One thing that we could do, I mean, this is not very hard at all, really. Acceleration, remember that when you take the derivative of velocity, you get acceleration, okay? One thing that I like to do when I'm doing this problem is I go ahead and find the derivative of this, so b prime at t. Now, I mean, they could have asked the question, is Bob speeding up or slowing down at t equals 5? Alright, and I could get, we could have a discussion on that, but right now they're just talking about Bob's acceleration. So when you take the derivative of the velocity, you're going to get acceleration. Keep that in mind, okay? Just remember that. Now I'm going to do this. Now this is going to be 3t squared minus 12t, and remember the derivative of a constant is 0. So now at t equals 5, you can simply plug that in. Okay, this is, you can do a lot of this by hand. So really, now we say a at 5 then is equal to 3 times 5 squared minus 12 times 5. Alright, I know this is 60, this is 25 times 3 is 75. 5 squared first. Alright, 25 times 3, 75 minus 60. So this is equal to 15. Now, what's the units? If we are dealing with meters per minute on velocity, then the acceleration is going to be what? Meters or what? Yeah, that's right, minutes squared. Okay, or we sometimes say per minute, but anyway, minutes squared. Alright, there it is, 15 meters squared. That's basically all you had to do to that one. Okay. Alright. Alright, and then I want to do D as well. That was pretty straightforward, wasn't it? I mean, you really don't need a calculator for this. Okay. I could show you something that you could do. You could put this into, let's say, y, or y sub 0 or y sub 1, and then you could pull up, get into y vars, and it'll come up with a string. Mine starts at y0, y1, and y2. So if you have this as y0, well, I usually put this as y0, but I had it, doesn't matter. Let's just put it right here. 3t squared, 3t squared minus 12t. Then you could pull that up, and it could come up y sub 0 at, and then you could put the 5 in there, and it will come up with 15. So you'd have to get into y vars, but you got to put this in y first. Okay, y sub 0, y sub 1, y sub 2. When you pull up y vars, you're going to get this list. Y0, y1, y2. You got to pick out, it's already in there, so you already know it's in there. You just pick out y sub 0, and then you put parentheses, and then put 5 in there, and that should do it. Okay. Alright, well, that's another way to do it, but I mean, this is easy to do it by hand, so that's pretty quick and easy. Alright, no problem there. Alright, so now let's look at part D. I think we have time for part D real quickly. Alright. Yeah, we've got plenty of time. Okay. Alright, let's look at part D. Excuse me while I erase all this. I'm sorry. Just some things that you can think about to do to make your life a little simpler, because I know you're on a time, you're timed on this. So anyway, alright, we're looking at Bob's average velocity. Now remember, the interval is t is between 0 and 10. So you got to remember that when you're dealing with average velocity. You got to remember that this is going to be 1 over 10 minus 0. Right? You got to remember that. Average anything like that. And just keep in mind, now the velocity equation itself is, let's see, I want to say it was b at t, b at t. I think it was equal to, let's see, what did it have? T cubed minus 6t squared, 6t squared plus, let's see, 300. Okay. Alright, like that. And average velocity would be, okay, we are going from 0 to 10. Alright, like that. We need to kind of keep that in mind. Now remember, when you're doing average velocity, you're saying you want to find distance divided by time. Alright, so that's what that is. It's distance divided by time. Well, distance over time is velocity. So to do that, you still got to do, it's still got to be, and I'm just going to put b at t dt. Okay. And here's what I would do if I were you, and this is me. This is just me. I would go to, you know, y equals, and I have y sub 0 on mine, and I would put this in there. All right. Okay, like that. I would put that in there. All right. And then what I want to do, I want you to understand there is a y vars. you get to y and then y bars, and I think from there you can get into your problem. And then this list will come up: y0, y1, y2, etc. You're going to choose y of 0. Alright, so what it really looks like is 1 over 10. Put that in there like that, and you're going from 0 to 10, and then you just put y of 0, and then of course it's going to be dx on your calculator. And when you do that, you can come up with your answer. Of course, you can take the antiderivative of this just as easily. I mean, this is not a difficult antiderivative to take if you want to do it that way. That would be alright as well. I'm just saying you could, if you're using your calculator, you can get into y bars. And believe it or not, I was going to get my phone and show you, but I don't see my phone in here. Excuse me for 1 second. Maybe I left it in the other room. If not, I'm not going to be too long, but I just want to let you know. I believe I've already done this one before. Let me get my phone. Okay. Excuse me just for a moment. Well, that was easy. I could not find it. I probably put it in my other room in there. I've got another room. And so I probably have misplaced it. I'll probably find it in just a few minutes. But anyway, be that as it may, you can do this. And then the answer is going to show up as, okay, so 1/10. And I think by the time you do this, your answer is 350. And remember, it's still going to be meters per minute. Alright, meters, let me erase this part, I'm sorry, meters per minute. Okay, that is what you're going to do. Now you got to remember, this is why you use this. You don't use the derivative of this or anything like this. You want to take the antiderivative of this to get distance, but that's the distance divided by time, and that's how you do average right there. Average velocity. You're still getting back to velocity again because you found distance here, and then you divided it by time. So most likely you got 3,500, and then you divide, that's your distance divided by your time, and then that's going to be 350. So there it is right there. Well, anyway, that's it. Those are things you just got to kind of keep in mind. Well, how do I know what goes here? And again, if you put this in y of 0, it may be that yours is y of 1. You may start off with y of 1, and that y bars is what gets you to this list here. And you pick out the one that you want. So if you got it in y1, pick that one. Okay. Mine was y of 0, so naturally I picked this one. Okay. I had mine in, I already know by heart, I had that in my calculator like that. So anyway, there it is. Alright, so we looked at, basically we looked at the meaning of total distance, and then we looked at a function, and we looked at the acceleration. That was pretty easy. I mean, you take the derivative of the velocity, you have acceleration. And then this one here, this is what hangs people up sometimes, but we just have to be really careful with that. Okay, there it is. Alright. Well, anyway, this is KP the Math G, I appreciate everyone here. I made this cap special for this occasion, KP. I don't have the Math G up there, but still, I am KP the Math G. And again, if you would like to subscribe, please subscribe. If you would like to make a comment, please make a comment. If you like that like button, you see I'm already smiling. Put that like button, hit that like button. I love those likes, I tell you. Anyway, I appreciate everyone here. If you don't do any of that, I just hope you get something out of this. Because it's not about me and my glory, it's about you and what you can get out of this, okay? KP the Math G signing off. Have a great, great day.